Okay, so what's one thing that you know, looking at it?
Acceleration is 3 seconds per meter.
Okay, so acceleration is 3. Okay, what else? And now notice acceleration is a constant of 3. So that means that it's always 3. Okay, what else do we know? Okay, v of 2 is 10. And what else?
It's 10 at 2 seconds.
It's 10 at 2 seconds. Okay, good. So how do we get to velocity if we have acceleration? Oh, antiderivative, yeah? So, yeah. So integral. So the integral of acceleration is velocity. And then what is the integral of 3? 3t, right? Normally we'd use x, but since it's time, we'll use t. Okay, plus c. And then how do we find our c? Yeah, which one is 10 going to be? Left or t? Left. And then our t is 2. So 3 times 2 makes that a 6. 6 plus what is going to be 10? 4. So then I'm going to come back to right here. I'm going to cross that out, make my velocity 3t plus 4. So far, so good? Okay, then it says, how far does the particle travel during the time interval when its velocity increases from 4 to 10? So how are we going to know what times those are? Because we know we want to integrate our velocity, 3t plus 4. But how are we going to know what to put here and what to put here? Yeah, we know v of t has to be 10 at one of the times, and what's the other time? 4. So let's set v of t equal to 4. So v of t is 3t plus 4 equal to 4. What time would that be? Yeah, minus the 4 over. 3t is what? 0, which means t is 0. That's our first number. I'm going to put that down here as the bottom. And then we want to go from when the velocity is 4 to when the velocity is 10. So that's going to be the key to finding the end of the interval. So I'm going to let my 3t plus 4 equal 10. Well, what would I need to do? Okay, minus the 4. 3t then would be what? 6. T is 2. So that means that I want to integrate from 0 to 2 of my 3t plus 4. Yeah? Okay, what's your antiderivative here? Uh-huh. 3 halves t squared plus 4t. And then remember, if you have endpoints, you don't need the plus c. You can put it, but the top and the bottom would both have a plus c, and when you subtract, they cross out. So then on top, we're plugging in 2. What's 2 squared?
4
Times 3?
6. Wait, no. 12.
And then divide by 2.
6.
Okay, 6 plus. Then we're plugging in 2 here. That'd be an 8. 6 plus 8 is 14. And then on bottom, we're plugging in 0. Well, plugging in 0 is just going to be 0. And then you take those and subtract.
Wait, yeah, 0.
Yeah? Because you're plugging into this one where they both have a t with them. Make sense? Okay, so look at the next one. We have velocity. We want to know how many meters the particle traveled. What are we doing? Kind of same thing as last time. Integral. Where to where? 0 to 4. And then it's 3t to the 1/2. And then 5t to the 3/2. Okay, so I'm going to give you a minute working with a little bit of fractions here, but remember, you're going to add 1, then divide. You will end up with fractions for your powers and fractions in the front. Okay, what's your first antiderivative? Add 1, what do you get? T to the 3/2. And then if I have to divide by 3/2, that'd be a... Oh, here, you're my last one. I'll take it. Okay, 2/3 in the front. Okay, then my second one. Add one.
There's a 3.
Huh? Oh, there was a 3, thank you. So I'm going to put that in the front and then those will cross out, yeah. Okay, then from there my t here was to the 3 halves.
5 halves.
5 halves, multiply by what?
5, so it's just 3.
5 times 2/5 in the front. And then just like Nani said, these guys are going to cross out here on the 3's, here on the 5's. So really my antiderivative is 2t to the 3 halves plus 2t to the 5 halves. Then from there we're plugging in 4. So that would be 2, 4 cubed and square rooted. 2, 4 square rooted to the 5th. And remember, the bottom number is the root, the top number is the power. So what is the square root of 4 here?
2.
Cubed times 2?
16.
16 plus. Square root of 4 is still 2. To the 5th power is 32. I'm sure you could have figured that out. And then times by 2 is 64. Add those together, what do you get? Okay, 80. Then on bottom we're plugging in 0, which is the best because it's just 0. And then 80 minus 0 is 80. Good job. Make sense? Alright, next one. For time t greater than 0, the velocity of the particle is given by blah, 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 blah. At what time is the acceleration equal to 0? Okay, pretty straightforward on the instructions. We need to find acceleration, set it equal to 0. How do you find acceleration if this is velocity? Derivative. What rule do you need? Product rule and chain rule, so both of those are right. Okay, so we're going to do u equals v equals. U is t minus 5, v is t minus 2 squared. So if u is t minus 5, what's du? 1. Then for my, oops, normally I call that u prime. I don't know why I put du. Thinking of chain rule here. Okay, v prime, what would that be?
2t minus 2 times...
Times 1, and you can put the times 1 or not, it doesn't matter. Okay, but the derivative of the t minus 2 would just be a 1. Okay, then from there I can put acceleration equals. And then I'm going to do this diagonal first. Okay, but you could do either one first, it doesn't matter. So it'd be t minus 2 squared plus t minus 5, 2t minus 2. So far so good? What do we want acceleration to equal? 0. What do we have in common? Got a factor. Okay, t minus 2 is going to come out. And then from my first t minus 2 squared, I'm going to have one extra t minus 2 that stays behind. Plus. Then on my second one, remember the t minus 2 came out, but you still have all of that left. I would distribute. So it would be what?
2t minus 10.
Good. 2t minus 10. And then I would take that step in there a little bit further and combine like terms. So you have t plus 2t. How many is that? 3t. And then negative 2 minus 10 more? Negative 12. And can we factor anything out of that? 3. That leaves us with what? Yep. 4. So is 4 the only answer?
No, there's the 2.
Yes. Remember your t minus 2. We have to carry that down. So 2 and 4 would both be your places where that happens. And remember, almost always when you're setting stuff equal to 0, you're going to end up factoring at some point. Okay? All right, turn the page. Oh, okay, cool. All right, good. The next one's kind of weird. Give it a shot, and I'll bring you. I only have Chips Ahoy left, so, but I'll come bring you one. Okay, and try to do something with it. It's very similar to the one that we just did. Very similar. John, what are you giggling about?
It's such a funny thing.
Anthony? Want one? Don, you want one since you're here?
Yes, please.
Like they're coming for the snacks. I see you. You want one? I want to leave you out.
hard.
Since you decided to come to school today, I'm proud of you.
I did work today.
You did your whole homework wrong and wouldn't fix it, but you did a little bit of work.
I tried.
Think about, in science, it doesn't count as work if you didn't move the object, right? You just kind of
I mean,
pushed something.
I
that didn't move.
tried. I filled up a whole homework page, and I haven't done that in like 2 weeks.
That's true. Filled it up with stuff that wasn't right, but you put something on there. Okay, we want it to be at rest. What has to equal 0? V, and how do you get to V if you have x? Not integral, derivative, yeah? Because this is the same as position. So anytime that it says at rest, you want velocity to equal 0. So if you haven't already, go ahead and take your derivative. And then after you take the derivative, what are you going to set it equal to? 0. Good. So see if you can get somewhere with that. Okay, let's check your product rule. What's the derivative of t minus a? And t minus b? So you cross multiply, you get t minus a times 1, which I'm not going to put, and then plus t minus b times 1. Yeah? Okay, now if you're not distributing anything, then you can get rid of those parentheses. You don't need those. So I have t minus a plus t minus b. What can I combine out of those that's a like term? T, so that'd be 2t minus a minus b. Okay, now question. We said earlier we're setting this equal to 0. What will be our next step to solve for t? Okay, I could move t over, but since I don't really like negatives, I'm going to take these negatives across instead. You could move the t across and negatives would cross out later. So my 2t equals, my a and my b are both now positive, then divide by what? 2. Make sense? Okay, so kind of weird in the way that it's set up, but algebraically doesn't really actually come out to be very hard. Alright, look at the next one. We did a little bit of this today and last week. Says the particle moves in a straight line. The graph of the particle's position at time t is shown above. So I'm going to put, normally they give us velocity graphs. This is position. Okay, then it says the graph has horizontal tangents at 1 and at 5 and a point of inflection at 2. For what values is the velocity of the particle increasing? Okay, so is this a graph of velocity? No. So let's think about what is velocity in this graph, the slope. And what is acceleration in this graph? What's the next derivative? You know it. Yes. And it's weird because normally they don't test it this way, but remember, if this is my y value, the first derivative is slope, the second derivative is concavity. Okay, so think about, if I want velocity increasing, then I want v prime to be positive. What is v prime the same as? Acceleration. So what do I want? I want a positive concavity. Okay, so think through that one more time if you need to. For velocity to be increasing, v prime has to be positive, and v prime is the same as acceleration. In my graph, acceleration's concavity. Where are we concave up? Thank you. 0 till, where did it say the point of inflection's at? 2. So I would have to stop at 2. So it'd be 0 till 2. Okay, next question. Using the same graph, determine when the speed is increasing. What is speed increasing? What has to match? 2 things. Okay, so I need to have the same sign for velocity and acceleration. Okay, but now remember, this is a different graph. This isn't our velocity like we're used to. So how will I know if velocity is positive or negative? What are we looking for? Velocity is the slope, and then acceleration is concavity. So I'm going to give you a minute to look at it. You want your slope and your concavity to match each other. Slope and concavity have to match. So if it's an uphill slope, you would have to be concave up. And if it's a downhill slope, you would have to be concave down. Where's the first interval that happens? 1 to 2, I'm uphill, concave up. Where else? 2 to 3, I'm uphill, but remember my concavity's already switched to down. So when all of this, I'm concave down, 5 to 6. Yep. So it'd be from 1 to 2, union, 5 to 6. Now, does that make sense why that's different? Because we didn't have velocity, we had position. Good? Okay, all right, next one. Good job. All right. Go ahead and read through it. Part A says, when is particle P moving to the left? When is particle P moving to the left? So, yeah, middle drawer. So particle P is my ln one. Can I use x of P? What does x stand for? The position. So if I want to know if it's moving to the left or the right, I need to know what? What tells you which way it's going? Position? Which one? Velocity. So I need to take the derivative. Now, do you guys remember the derivative of ln u is u prime over u? So if this is my ln function, when I take the derivative, I have to put the derivative on top and the original on bottom. So for question A, I'm going to put Vp of t equals x prime of t. Then I'm going to put that little p back down there. And now I'm going to take the derivative. So u prime is going to go on top. What's the derivative of u prime there?
2t minus.
And then on bottom, remember, you keep your u exactly the same. So it would still be t squared minus 2t plus 10. So the top of it is my u prime, the bottom of it is my u. Okay, then from there, what's my critical number on the top when I factor that? What can I take out? 2. What's left over? T minus 1. Good. And then on the bottom, you could try to t-chart that, but it's not going to work. What's the only way you could times to 10? 2 times 5. And what's the difference between 2 and 5? 3. So this is not going to work. We're going to keep this the same. Okay? So what's our only critical number then off the top? T equals, you were right the first time, 1. Because it'd be what would make that 0. So set up your line chart. 1 is my only critical number. I'm going to plug in 0 because 0 is easy to plug in. So 0 minus 1 on top, what's the sign? Negative. And what's 0 plus 10 on the bottom? Divide a negative and a positive, what do you get? Negative. Now, remember in class sometimes we're lazy about these, but this is velocity, this is position. Okay, next let's plug in 2. On top, what's 2 minus 1? Positive or negative? Positive. Okay, then down here, 2 squared minus 2 times 2 is 4. 4 minus 4 crosses out, it stays positive. Positive over positive is? Good. So when is our particle traveling to the left? Which interval? 0 to 1. Left would be 0 to 1. Now, it did not say to justify, but if it did, you'd say because v less than 0. Yeah? And then this would be down and then up on your line chart right there. Okay? All right, go to part B. Find all the times during which the 2 particles travel in the same direction. Now notice, this is already particle X. Or X, let's say particle P. So what's the only particle I really care about? Particle Q. We already did all the work for P. So we just have to put q underneath it. So look at your v of q. Do we need to take the derivative of that one? Yes or no? No, why not? What'd they already give you? Velocity. So we don't have to worry about taking the derivative because they already gave you velocity to start with. Okay, factor that for me. What do you get? Multiply to 15, add to negative 8. Good. Minus 3 and minus 5. And order there doesn't matter as long as you get both of them. So what are our two critical numbers? Okay, 3 I'm going to put here. 5 I'm going to put here. Now notice I do want to kind of line them up so that my 1 is lined up before the 3. So don't put like 3 over here in front of 1. Okay? Then from there we need to do a line test. Let's say we plugged in 0. 0 minus 5 is negative. 0 minus 3 is negative. Multiply two negatives, you get a positive. Say we pick 4. 4 minus 5 is negative. 4 minus 3 is positive. Multiply those together. Negative. And then if I pick something bigger than 5, they both come out positive. Times them together, it stays positive. That means that our second particle, this is particle Q, was going up, down, up. If we want them to be going in the same direction, what do we want their velocities to be? The same sign. So look at your intervals. Try and see where that happens. I'm going to give you a minute to look at it. And I would just maybe shade them or circle them or something. So from 0 to 1, do they match? No. 1 to 3, do they match? Yeah. Both positive. Okay, from 3 to 5, do they match? No. 5 to infinity, do they match? Yeah. Yes. So those would be your intervals. 1 to 3, union, 5 to infinity, because, and then it is, the only thing that's kind of annoying with this question is since you have the two V's, you want to make sure you call one VP of T and the other one VQ of T. Have the same sign. So remember, the direction that a particle is going comes from its velocity. Okay, part C, find the acceleration of particle Q at time 2. How do we find acceleration? Derivative of what? Of velocity. So velocity's here. And remember, we're doing particle Q, so we want to make sure we're looking at the right thing. What's the derivative of this? 2t minus 8. And then when do we want the acceleration? At time what? At 2. So 2 times 2 is 4, minus 8 is negative 4. Question, is that all that we need to know to determine whether the speed is increasing or decreasing? Only acceleration. You also need to know velocity. So if I wanted to know velocity at 2, you have two choices. You can plug in velocity at 2, which is what I'm going to do, or you could look at your sign chart. So remember, velocity's here. So what's 2 squared? Be 4 minus 8 times 2 plus 15. So that'd be 4 minus 16 plus 15. What is 4 and 15 together? 19. Take away 16 is 3. So overall, did it come out positive or negative? Positive. And if one of them's negative and the other one's positive, what's your conclusion? Very good. Therefore, speed is decreasing. Okay, I'm going to write something wrong, and I want you to try to think about why it's wrong. Because AQ of T and VQ of T have opposite signs. Okay, something's wrong with it. What is wrong with it? Yes, it's not at any time. When is it at? At 2. So you want to make sure that's a 2 and that's a 2. The other way you could get around it is you could put at time 2 and then say it, and then it's fine. but you have to say something about 2 there. Okay, then part D. Find the position of particle Q the first time that it changes direction. If we have velocity and we want position, how do we find position? Do we do the derivative or the integral of velocity? The integral, very good. So for position, I'm going to need to integrate my velocity formula. So take the integral of this, write it on your paper. Okay, I'm going to put xq of t, which I know is getting kind of annoying, but we're on the last part. Okay, so it'd be the integral of velocity q of t. The first term was a t squared. What's the antiderivative of that? 1/3 t cubed minus. Next term, we're on the 8t. Antiderivative of 8t is what? 4t squared plus antiderivative of 15 is? Plus? C. You have to be able to find C. What did they tell you? Look back up at all your junk. Yep, right at that last sentence it says particle Q is at position 5 when time is 0. So that's going to be the last piece we need to find C. So if 5 is the answer and I plug in 0 minus 0 plus 0 plus C, what's C? So I'm going to cross that out, put a 5 there instead. Now, when did they want the position? At the first time it changes direction. Well, lucky for us, we already did that. Look at particle Q's sign chart. When did it change direction the first time? At 3. So with the 2 particles, you just have to kind of make sure you're paying attention to the right one. So particle Q changed direction at 3. And remember, you do not have to work it out. You just have to plug it in. So it'd be 1/3 of 3 cubed minus 4 times 3 squared plus 15 times 3 plus 5. And then you leave it alone. Unless there's multiple choice or something, you should not simplify that all the way through. Okay? Now remember all this junk? Good. Okay, go to the next one. We just did an ln one. Oh well. Okay. Look at part A. So we have our equation right here. What is that equation for? Position, velocity, or acceleration? Which one? Velocity, good. So part A says, is the particle initially traveling towards or away from the origin at time 0? What do we need to do with 0? Okay, plug it in. So V of 0 equals ln of, and then if this is 0 minus 0 plus 3, that would just be ln of 3. Okay, now this is where your knowledge of ln's is going to maybe mess you up on this one. When does, I'm going to draw a little sketch over here. Here's e to the x, yeah? Here's ln x. Remember, they're inverses, so they're like flipped of each other. What is this point here? On E. 0, comma what? 1. So then what is this point here? Remember, they're inverses of each other. 1, 0. So if I'm at 3 on my ln graph, am I on the negative part or am I on the positive part? The positive part. Because I'm after where it hits the x-axis. Does that make sense? So remember that ln turns positive after 1. But before 1, it would be negative. Okay? Now, is only knowing that velocity is positive enough to answer the question?
Bye, Mr. Turner.
Bye. Have a good day.
Me too.
What else do we need to know? I just boxed it for you. Okay, the position at 0 is what? 8, which is positive. So that means that my particle is on the right side and it's traveling to the right. So what's our conclusion? Towards or away? Traveling away. Good job. Make sense? And now on the ln thing, there's not a good chance that you'll have to know that, but they've done it a couple times. Okay, part B, find the acceleration at time 4. How do you find the acceleration? Okay, integral or derivative? Which one if we have velocity? Derivative. So we're going to find v prime of t. And then remember we just did the rule for ln. So remember it's going to be u prime over u. So think about that for a second. U prime over u. What will u prime be from that middle? Okay, 2t minus 3 over. And then remember the bottom stays the same. So it'd still be a t squared minus 3t plus 3. Okay? So it says find the acceleration at 4. So then once I find acceleration, now we need to plug in 4. So that'd be 2 times 4 on top is 8. Minus 3 is what? 5. And then on bottom, 4 squared is 16. Minus 4 times 3 is 12. Plus 3. 16 minus 12 is 4 left over. Plus 3 more is 7. Okay, second question. Is the speed of the particle increasing, decreasing, or neither? So we know our acceleration. The other thing we need is our velocity. And it would be the ln of 4 squared minus 3 times 4 plus 3. And that should look familiar. That's exactly the crap we just plugged in on the bottom, right? So what did that come out to be? 7, which is positive. So if they're both positive, our conclusion would be that yes, speed is increasing. Okay, let's skip that last part since we just did one like that. Okay, next one says second part B. Okay, find the times in the open interval at which the particle changes direction. During which intervals does the particle travel to the left? Okay, so we want to know when our particle changes direction, are we going to set the derivative equal to 0, or are we going to set the original equal to 0? For a particle changing direction, what has to change sign? Okay, so the position is going to have to change direction. Then we want v of t to change sign. And now remember, v of t is what they already gave you, right? So we're going to set 0 equal to the ln of t squared minus 3t plus 3. So far, so good? Okay, how do we solve this? Think outside the box. And I added this part. This wasn't really on the AP test. But you should be able to do it. What would you do first? E. What happens with E and ln? Cross out. And what is e to the 0? 1. Okay, then what would we do next to find our critical numbers? Minus the 1 across. So 3 minus 1 gives us t squared minus 3t plus 2. And how can that factor? We need numbers that multiply to 2 and add to negative 3. Minus 1 and? Good. So what are our two critical numbers? 1 and 2. Very good. Okay. Then it says, when does it travel to the left? So you'd have to set up your sign chart. Remember that for velocity, when you're talking about a particle, almost always, like look up here, it'll say like t greater than 0. So you don't have to go back to negative infinity. Technically on this one it says I can also stop at 5. So 1 and 2 go in here. Say I plug in 0. What's 0 minus 1? What's 0 minus 2? Double negatives multiply out to a positive. Okay, between 1 and 2, let's say we pick 1.5. What's 1.5 minus 1? 1.5 minus 2? Overall? Negative. Okay, and then for our last one, between 2 and 5, say you pick 3, they both come out positive, so it'd be positive overall. So it would be up, down, up. When is our particle traveling to the left? 1 to 2. Very good. Because V of t is, less than 0. Okay, and then you should label your chart here. That was V of t, that's position on the top. Okay? Alright, C and D, both of those have integrals in them. Try to set them up. I'll give you a minute. This will be our last question that we're finishing up. So try to set up C or D. Oops, I meant this second one to be different. Change this one for the average velocity. They both say position, that's my bad. Both of them are going to have an integral in them, but they should be different. What would I put for C? I want the position at 2. When do we know the position? At 0. Very good. What was the position at 0? 8 plus, and then I'd have to integrate from 0 to 2 of velocity. So you could set it up like that, or you could put 8 plus, and then the integral 0 to 2. Now, just to make you feel better about yourself, okay, this question you actually had a calculator for. So you wouldn't have had to do all the E stuff by hand. But it's good practice, because you never know. Okay, last part. We want average velocity. What would that be? Is it average velocity? Is it A rock, or is it 1 over B minus A?
1 over B minus A.
1 over B minus A. So it'd be 1 over 2 minus 0. And then your integral 0 to 2 of velocity. And remember, if it's average velocity, you should have velocity in the integral. If it was average acceleration and you were using that formula, you'd put acceleration here. Okay? Make sense? Good. All right. Good job. You guys have your sheets? There you go, ma'am.